Hello, Physics Nation. My name is Nate Larmond, and it's craft time yet again. We are going to make a pulley this time. You can do all sorts of awesome physics experiments once you have a low friction pulley. This is called Atwood's machine. George Atwood actually hung out with Isaac Newton and wanted to see if Newton's second law could accurately predict the mathematical relationship between force, mass, and acceleration. So he made this apparatus right here. Let me see if I can zoom in. We're going to make a much more simple, hang on. We're going to make a much more simple version, but it's just basically a pulley with a weight hanging off one side and the other. And this is a pendulum to keep time. And, this falling weight would smack these different platforms with a ruler on the side. So this is called Atwood's machine. What's up with the little surcharge, the extra amount that allows it to move with a constant velocity? We'll get into all of that later. Oh, here is Newton's second law, F equals ma, as it's famously called, or acceleration is directly proportional to the net force and inversely proportional to the mass. So a pulley is a wheel, basically, and we're going to make 4 circles out of cardboard. 2 of them are the outside diameter of the Dollar General masking tape, and 2 of them are the inside diameter. So you make a little cardboard hamburger here with the big guys on the outside and the little guys on the inside. The purpose of that is to make the profile of the pulley wheel look like a valley right here. You're going to put the masking tape into the valley and then sort of squish it into the groove. I used my scissors here. And, I should have done a better job of explaining the complicated part of the build, and that is the paperclip. Let me zoom in again. This little piece of metal is the tricky part. So, hopefully you can grab some needle nose pliers. These allow you to bend metal to very precise angles, and you're going to make an L and then pass it through the cardboard, and then you bend it into a U. So that wasn't the greatest explanation. This is a U. Let's see. It's right there. And the paperclip acts like the axle. Anyway, this is how it looks. It's pretty magical. There you go. And like I said, what it allows you to do is play with forces and mass independently to actually confirm or refute this, Newton's second law. The technical vocabulary is pretty simple. Looks like an E. It's actually a Greek sigma. It's telling you to add up all the forces in this case. The system is up to you. I like to analyze these systems as one big piece of mass. So you have one weight pulling on this side and the other pulling on this side, and they provide counterclockwise torques. And that allows you to find the difference in the 2 weights. That is the net force acting on the system. Now, there are other ways to do this, but I think the whole system approach, as they call it, is easier. Equilibrium just means a state of balance. So if a system isn't accelerating, if it isn't changing its velocity, it's in equilibrium. And that means no acceleration, which means no net force. If you add up all the positives and the negatives, you get nothing. And a Newton is simply the metric version of force, push and pull. As it's defined, it's the amount of force that it takes to move 1 kilo with an acceleration of 1 meter per second every second. So it actually starts with a pretty complicated craft. I've never asked you guys to build something like this before. So let's just leave it at that. Cut out your cardboard, glue it up, run the masking tape, make your axle out of a paperclip, and you should have a pretty magic pulley. Thanks for watching. See you in the next video.